Hello everyone. In this lecture, we are going to see the LM35 sensor implementation with Arduino UNO. This LM35 sensor is an analog temperature sensor and LM stands for linear monolithic and it gives the output value as analog and we will multiply with voltage and we will also multiply with 10 to get the temperature in degrees Celsius. We can also convert to Fahrenheit based on conversion from Celsius to Fahrenheit formula. And firstly, we will see only the implementation of LM35 sensor with Arduino. Then we are also going to interface the buzzer and LED. And in real life application, you can see that fire alarms are used in big industries. Even when there are also some of the smoke sensors are also available. For example, even if you light a small agarbatti also, it senses as a dangerous or some fire smoke and alarm rings, right? That is one of the application where we use this temperature sensor LM35. It is an analog sensor. In this video lecture, we are going to cover completely regarding this analog sensor. And in the next video lecture, we are going to see about digital temperature sensor that is nothing but DHT11. Now let me explain you briefly about LM35 sensor. Yes, LM35 is an analog temperature sensor. It consists of three pins. One is the voltage, middle one is the output, and another one is the ground. You can see that this has the two faces. This side it is in square shape. On that it will be written as LM35, and back side somewhat cylindrical in shape. If you are considering the first pin as VCC, you must observe the pins from the written text side one. Nothing but from the square shape, you need to observe the pins. Then this will become VCC, this will become out, and this will become the ground. If you take in reverse, first will be the ground, then middle one will be the analog output, and last one will be VCC. So you need to take care while giving the connections. Now let me explain you the program. Yes. Now for LM35, I have since it is an analog one, we need to consider one of the analog pin. I have considered A1, and in setup, I am just going to begin the serial monitor. This is without the LED and buzzer implementation. Firstly, I will explain simple LM35 implementation. Then we can go with the buzzer and LED implementation along with LM35. Yes, I am considering a value and one more is the temperature value. This ADC value is given by the sensor. It is not directly in terms of Celsius. So firstly I am reading the using analog read I am reading the value of the sensor. That will be the ADC value. I hope ADC value, most of you know, it is nothing but analog digital converter value. So we need to multiply with the respective voltage. Actually, the actual value that must be taken is 4.88. But most of the people use here 5 or 3.3 volts. The reason is that in our Arduino, there are only two voltage pins. The one is 3.3 volts and another is 5 volts. But the correct value to be taken is 4.88 as it gives the 100% accurate result. So we are multiplying the sensor value with 4.88 and then we are dividing the value by 10 so that we will get the correct value in terms of Celsius. Here you can see the when I am multiplying the temperature value with 4.88 and I am dividing by 10, you will get the temperature value in Celsius. Similarly, you can also convert to Fahrenheit too. Yeah, here you can see that one more thing I want to mention is here how to get degrees in output. Here you can see that it will be printed a normal number and then degree Celsius. Instead of that, how to keep degree on like this, you can see on top of a number that we are going to see now. Yes, to get in terms of degree, you need to make use of these two lines. You can remove now this degree Celsius statement. Yeah. This is nothing but Celsius. And this is the thing you need to give in the print statement to get in terms of degree. Hope you understood. Now just let me compile it. Yes, there are no errors and I am giving 1 second delay for every value. Now let us see the connections. And before that, like for every experiment I have done, we are not going to waste much time from now onwards. We are directly going to rush faster in order to cover more and more topics. Now, I have given a pin for sensor. Now similarly I am also going to give for LED and buzzer. At a time we are going to implement everything so that we can go faster. For LED let me give digital pin value as 9 and for buzzer let me give it as 13. Yes. One more thing is that the advantage of this sensor is that you need not declare the pin as an input value in case of void setup. But if you want also you can give, it's not an issue. Now I am going to give pin mode. For LED I am going to give as output. For buzzer also I am going to give as output. Yes. Now, actually, we are going to see the variation in temperature. So that let me also consider here. Let me write if temperature value greater than 32, then my LEDs should on. For that, I will write the function digital write of LED comma high. Similarly, for buzzer also we are going to write digital write of buzzer comma high. Now in else condition we are going to make them low. Copy, low, low. Yes. Now let me compile the code. Yes, there are no errors. Now we are going to see the hardware components connection. Firstly, I will connect the LM35, then simultaneously I will connect the LED and buzzer, and we are going to see the application. Yes, friends. Now you can see that my Arduino UNO is connected to my laptop and LM35 is connected to Arduino UNO. You can see the output is connected to analog pin A1 as per our program and VCC, nothing but the first pin voltage is connected to 5 volts and the last one purple color wire is connected to my ground. Now we are going to connect the buzzer and LED also to Arduino UNO board. Yes, now my LED positive and negative are connected. LED positive, nothing but the brown wire is connected to the digital pin 9 and negative is connected to the ground. Now similarly I am also going to connect my buzzer. Yes, now my buzzer also connected. My buzzer positive, nothing but red is connected to the digital pin 13 and buzzer negative, this yellow wire is connected to the ground. Now I am going to just upload my code. Yes, my code is uploaded and you can see the temperature value is also being printed here. Here you can see you are getting after the number you are getting in power you are getting as a degree, and you can see in Celsius you are getting this value. You are getting approximate values, right? Now I am just going to bring my agarbatti smoke towards the sensor, and you can see how much variation you will get in the temperature and how LED and buzzer are going to operate. Just a second. Yes friends, now you can see that there is no sound and all. Now I am going to just bring the fire near the sensor. You can see slowly the temperature is increasing. Slowly the temperature is increasing and you can see buzzer and LED are working. Since 32 degrees is exceeded, you can see temperature is also keep on increasing. Now just let me move it far away. You can see slowly there will be fall in temperature. Yes, now temperature has decreased less than 32. So you can see now LED and buzzer both are off. Once any smoke or any some fire is detected by the sensor, the temperature increases steadily and the buzzer and LED both will be in high. And this is how we are going to make use of this LM35 sensor along with buzzer and LED in building and fire alarm. This is how it works, and in the next video lecture we are going to see the implementation of DHT11, the digital temperature sensor with Arduino UNO, similarly with buzzer and LED. Thank you.